use variation of parameter to solve the given system. So to use parameter method, here's the steps you need to do. First, you need to find homogeneous part, then find non-homogeneous part, and add them together, which gives you final answer. So here's the steps you need to do. Okay, so for a specific problem, I will walk you through it step by step. Now let's put this aside. So for this one, first, same as usual, find a minus lambda I. Let's call this matrix A subtracted with lambda I. It gives you this matrix. Then find its determinant. That gives you this one. Simplify it all the way down here. Set it equal to 0. Solve for lambda. You will get lambda equals 2 and 1. Okay, so you have a repeated eigenvalues because here 3 by 3 matrix, so you need to have 3 eigenvalues. Okay, let's figure out what those eigenvectors are. So for lambda equal to, plug it into a minus lambda I, you will get this matrix. Reduce it by reduce this to base matrix, you will get an infinite solution. And if I have a vector k, I have k1 equals k2 plus k3, k2 is k2, k3 is k3. Then if I factor out k2, I have vector 1, 1, 0 plus factor of k3, I have vector 1, 0, 1. And since these two vectors are not a multiple of each other, I have two linearly independent solutions. So I have vector x1 is equal to 0, 1, 1, 0 times e to the 2t. My solution for vector x2 is equal to 1, 0, 1 times e to the 2t. That's for lambda equals 2. Now for lambda equals 3, for lambda equals 1, plug it into a minus lambda I. That gives you this matrix augmented with 0. From second equation, I know that k1 is equal to k3. From the third equation, I know that k1 is equal to k2. If I choose k1 1, then k2 equals k3 equals 1, and my vector k is 1, 1, 1. Then my vector x3 is equal to 1, 1, 1 times e to the t. Then my homogeneous solution part is equal to c1 times vector x1 plus c2 times vector x2 plus c3 times vector x3. Okay, so that's your homogeneous part. Now let's take a look at non-homogeneous part. So same as a minus lambda I. First, you need to have vector phi, which I obtained from homogeneous part. Okay, so let's look at this. So your homogeneous part, basically you exclude c1, c2, and c3, then put out the rest into a matrix. Okay, then you need, after that you find the determinant of phi, which is negative e to the phi t. Okay, then to find its inverse, first you need to find the cofactor of phi. So how? So let's take a look at the first entry, the first row. Cover, block this column, block this row. You have matrix 0 e to the 2t, e to the t, e to 2t, et. Okay, for second entry, block this column and this row. You have this matrix e to the 2t, e to the t, 0, e to the t. The entry of the first column, third entry of the first row. Block this column, block this row. You have e to the 2t plus 0, 0, e to the 2t, and then you repeat this for the rest. It will give you this matrix. Okay, then your next step is to find the determinant of each entry. So for this one, the determinant is negative e to the 3t. Okay, for this one, e to the 3t. This one, e to the 4t. This one, it is 0 e to the 3t, e to the 4t. This one, e to the 3t, 0, negative 2, negative e to the 4t. Okay, and then after you have those entries, you need to find their size. So by convention, you always start with positive, and then you are going to alternate it. So positive, negative, positive, positive, negative, positive. So here you have negative, then positive, negative, positive, negative, positive. Okay, then after I simplify this, I will get a new matrix, which is this one. So negative e to the 3t, negative e to the 3t, e to the 4t, 0, e to the 3t, negative e to the 4t, e to the 3t, 0, negative e to the 4t. Okay, then your actual matrix is your transpose of this matrices. So So the inverse matrix phi is equal to 1 over the determinant times the transpose of your cofactor matrix. So how to find the transpose of the covector? So very simple. You take this row and put it into a column. Okay, take this row, put it into a column. So basically you have this row, right? Basically you have this row, and then now you put it into a column. So horizontal becomes vertical. So horizontal becomes vertical. Second row becomes second column. Third row becomes third column. Okay, and you multiply this with 1 over the determinant, it gives you this matrix. Okay, next step is to find the u prime, which is equal to inverse phi of t times f of t, which gives you this. Multiply them together, it gives you this one. Okay, yeah, let me double check really quick. So 0, negative t e to the negative 2t, and then 0, yep. So over here you have negative a positive 2 or 0, and then here is t e to the negative t, and then 2, yeah, positive 2. Okay, then the next step is to find the integral of this matrix. So integrating this one gives you this matrix. So for this one, it's very simple. You have positive 2e to the negative t. This one is a little bit tricky, but if you use the integration by part method, it's simple. So let u equal t, then dv equal e to the negative 2t, then the integration by part method, it will give you this answer. Okay, so that's simple. So I'm not gonna, it's easy and simple, so I'm not gonna go over it very detailed. Now for your non-homogeneous part, it is equal to phi t times u of t. So here's phi t, here's your u of t, what you just found. Multiply them together, it will give you this matrix. Okay, and this matrix is your non-homogeneous part. Then final solution is equal to homogeneous part plus non-homogeneous part. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.